All right, guys. So so today we're learning about real number system. It's just a bunch of vocab that you're going to need so that when you certain questions won't just ask you for like all the answers, they'll want just a few of them. And you should know a little bit of the history behind math also as well. Anybody here interested in becoming an elementary school teacher, somebody that teaches little kids? Anybody in here anybody in here have a little brother or sister, really young, like baby age? Yeah? Yeah? Perfect. So it's really interesting, at least one thing that I found fascinating, one reason that I wanted to be an educator, is I liked watching kids learn. I liked seeing how they process it. It could be the case that all of a sudden you don't understand something, you're never going to get it, and then all of a sudden it clicks into place. So speaking of which, your little brother and sister will one day, suddenly it will click into place and they will understand kind of how to count. What's the first way you think they're going to learn how to count? Yeah, they're going to use their hands. That's one way you can kind of tell if your little brother or sister is progressing normally in terms of like their intelligence. You know, and in fact, does anybody in here, you don't have to raise your hand, but people still count on their hands. That's okay, right? Does anybody in here know how to multiply with their hands using like the nines? Yeah? 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 Do you guys want to see it or are you going to take my word for it? It's really fast. Does anybody want to show? What you do is you hold up your hands, 9 times 7, right? All you do is start on this hand, count 1, 2, 3, 4, 5, 6, 7. Put that finger down, and 9 times 7 is 63. 63. See it? It's real fast. Okay, anyways. So in Latin, your fingers are called digits, and that's where the word comes from. Because learning to count on your hands is the most natural way to count, we call these first set of numbers the natural numbers. And some examples of the natural numbers. Some examples of natural numbers. The natural numbers start at 1, and then they just go on forever and ever and ever in that going up towards infinity. Okay, because you can just keep going on them. You know, and after the natural numbers, people invented one specific number because they realized that actually having nothing was having something. What number represents nothing? 0. My question to you is, and this is kind of complicated, is 0 positive or is 0 negative? It's neutral. It's neutral. And so 0, I always think, I love Dunkin' Donuts. I go to Dunkin' Donuts every single day, right? What does 0 look like? My favorite kind of donut. Those munchkin holes. You know what I mean? Oh, I love those munchkin holes. In any event, check that out. It even looks like a hole if you use your hand. The next set of numbers that evolved were called the whole numbers. And the only difference between them and the natural numbers is that the whole numbers have 0. And we're going to put them up over here. Right there. Yeah. What's up next are all the negative numbers, just the normal ones that you count with. These guys right here are going to be called the integers. Yep, the integers. And the integers are like -4, sorry, they keep going in the negative direction. -3, -2, -1, 0, 1, 2, 3, 4, ... They just go on forever. And the integers go right here. Yep. And then after the integers, oh my gosh, put it this way. If you get these kinds of numbers for answers, most people say I did the problem wrong. What kind of numbers am I talking about? Yeah, decimals and fractions. Decimals and fractions. In fact, decimals and fractions are going to be called a weird name in our class. What do you think they're called? Does anybody know the actual vocab? Decimals and fractions in this class in high school are going to be called rational numbers, right? So rational numbers is everything that's ever come before it, like -2. But -2 could also be written like this, -2/1. It's also -4 divided by 2. So there's all these different versions of it. You could put 0. You could put 0 divided by 1. We could put 1.5, or we could put 3 divided by 2. See, we have every basically different combination that we were looking for. We also, weirdly enough, have these. And this is what really screws up people. I mean, what happens when I put a bar over something? What does that mean? It keeps repeating forever. Forever. And 0.3 repeating in a fraction, does anybody know how much that is? 0.333333333. How much do you think it is? No? 0.3 repeating is actually a third. And so these guys right here, these rational numbers, they are going to go in this circle. So that's how things evolved. Natural numbers counting, whole numbers we added 0, integers we added negative numbers, rational numbers we got everything in between. Now there's one more weird category that we have to fill in. I wonder if anybody knows what the name of it is. Have you heard of anything called irrational numbers? Yeah? Can you guys think up an irrational number? There's like a real famous one. I don't know if anybody knows of it. Shoot. Is that what you were going to say? Yeah? Okay, let's write that down. Irrational numbers. Irrational numbers. Okay. And irrational numbers, let me give you an example of an irrational number. So here's my, that's annoying. Here's my calculator. You two will get one too. So everybody will be able to follow along with me at the board. There's actually a pi button on your calculator to use so much. Hit enter. My calculator stopped pi. Does it stop there though? No, my calculator just actually got too tired of putting digits down that it said, you know what, this is good enough for you. Just deal with it. Right? But pi goes on forever. 3.14159 pi equals 3.14159 ... And let me give you another one we're going to study, and people are going to freak out when we have to do this. But we're going to do radicals in this class also as well. Like the square root of 2. Oh my God, that's so annoying. Annoying. You know, 1.414221. Yeah. 1.41, what was it? 421. It goes on forever. There is no pattern. There is no pattern. And that's the major difference between irrational numbers and rational numbers. You see, this one over here, right, this 0.3, that bar over it means it also goes on forever. But this one has a pattern. Whoops, I'm sorry. Not only does it have a pattern, it has a repeatable pattern. And so we're going to go up over here. We're going to stick irrational numbers in this category right here. And that's all the vocab that you will really need for a lot of the questions, for the questions in this class. Together, every one of these categories comes under the category of being a real number. In Algebra 2 and Trig, which I teach before your class, we learn about imaginary numbers later on. But that's all you're going to need to know for